Welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe the channel. Really helps the channel to grow. In previous lesson we have discussed the coordination number. You know that the coordination number is the number of dative bond formed by the ligand with the central metal atoms. So when complex molecules are formed with the ligands, they have different shapes. The shapes of the complex molecules, today we will discuss the shape of complex molecules. Number one is the linear shape, and linear shape, for example, we have discussed this reaction in AS. You know that when silver chloride when we add dilute ammonia solution in silver chloride, it dissolves and form complex ions, and you know that the silver form dative bond with two molecules of ammonia, and ammonia is a neutral particle. So that's why silver carrying plus charge, overall charge is plus. So the shape is linear and angle is 180. So this is the linear. There is another example, platinum with two OH ligands. The overall charge is 0 because OH minus, there are two OH minus, so carrying minus 2, and platinum carrying plus 2. So this shape is also linear and form 180 angle, 80 degree in this complex, and overall charge is 0 because plus 2 is the platinum charge, and minus 1 and minus 1 is equal to minus 2. So charges are cancelled out. So this is overall charge is 0. Complexes may be neutral or anionic or cationic. So when there are two charges, like two hydroxide ions form dative bond with platinum, and platinum has two positive charge, so this will be cancelled out, and overall charge will be zeros. Next shape is tetrahedral. This is 3D shape and coordination number 4. Bond angle is 109.5 degree. So this shape, and you know that 3D shape can be drawn by drawing, you can draw any wedge line, any dotted line, any solid line, and you know dotted line represent that this is behind the screen, and wedge towards you, the bond towards you, and the solid line away from you. So tetrahedral can be shown like this. So this is towards you, and this is always draw lone pair of electron with ligands. So the angle is 109.5. So overall charge is minus 2. How we predict this charge minus 2? Because copper carrying plus 2 and 4 Cl negative ions carrying minus 4. So when plus 2, this is plus 2, and when plus 2 and total minus 4 charge is there, the overall charge will be minus 2. So in this way overall complex charge is minus 2. So platinum carrying 3 positive, ammonia 4 ammonia molecules are there. So ammonia is a neutral particle, so there is 0 charge. So platinum carrying 3 positive charge. So bond molecular geometry is like this. Tetrahedral, again 2 solid lines, 1 wedge and 1 dotted line. The bond angle is 109. So next shape is square planar 2D shape. Coordination number is 4, and this is the example of square planar structure. Cyanide carrying 1, cyanide carrying minus 1 charge. So 4 cyanide ion has minus 4. So the overall charge, it means manganese carrying plus 3 charge, and when plus 3 minus 4, there is minus 1. So overall charge is minus 1. So this is square planar. There is another example of square planar iron. 4 hydroxide ligands attached with iron atom which carrying +2 charge. Because overall complex is -2, we can predict this charge. OH carrying -1. So there are 4 OH molecules are there which form dative bond with iron. So 4 OH is equal to -4, and +2 carrying iron carrying +2 charge. So overall charge will be -2. Octahedral coordination number is 6, bond angle 90 and 180 degree. So if coordination number 6, so ligands form 6 bonds with the copper, and when 6 bonds are there, so draw 2 wedges, 2 dotted lines and 2 solid lines. Overall water is a neutral particle, so that's why 6 water means 6 zeros, 0 charge on water. So +2, so overall charge will be +2. So these 2 lines are one above and one below, and the angle in between these 2 lines are 180 degree, while draw 2 dotted lines and 2 wedges. So the angle this and this is equal to 90 degree. So there is another example when bidentate ligands attached with the central metal atom are ions. So this is the neutral particle which is represented with En, or it is ethylene diamine, and 3 molecules of ethylene diamine is attached with the manganese, which carrying +2, because these 3 molecules have 0 charge because it is a neutral particle. So it forms 6 bonds and overall charge will be +2. So the next topic is stereoisomers, isomerism in complex molecules. Is isomerism in transition complex. So isomerism, we know the definition of isomerism. The isomerism compound having same molecular formula but different structural formula. So in the complex compound isomerism, there are two types of isomerism: cis trans or geometric isomers, and second type is optical isomer. We have discussed earlier about the in AS optical isomers are those when two compounds are non-superimposable and mirror images of each other. So in complex molecules, when two transition complex are non-superimposable or mirror images of each other. And on the other side, cis trans, we have discussed earlier in AS that cis when two similar group of compounds are attached with one carbon atom, and trans when two different molecular compounds on the two sides. So cis trans geometric isomerism, although there are complex molecules do not have double bond, so they can still have geometric isomers when two pairs of different ligands are attached with square planar structure. They exhibit cis trans isomerism. So there are certain conditions, so you should know these facts before starting the isomerism. So first is that cis trans isomerism is only possible in square planar and tetrahedral and octahedral complexes. Octahedral complex molecules. Tetrahedral complex does not show cis trans isomers. Does not show cis trans or geometric isomers. So let's discuss the square planar complex molecule which shows the cis trans isomers. Square planar complexes which shows cis trans isomerism. So there are certain conditions in which square planar show cis trans isomers. Not all square planar complexes show cis trans isomers. For example, if central metal atom form dative bonds with 4 same type of ligands, is no cis trans. Isomerism. And if central metal and three same type ligand and one different ligand. For example, over here example is like CuCl4 plus 2, or we have discussed earlier like this example in square planar, iron 4 hydroxide. Minus 2. So, and if there is I have used generic name. For example, this is metal ion, this is ligand A, and this is another type of ligand B. If three ligands are A and B ligand is 1, then there is no cis trans isomers. So as long as a complex ion has two ligands different from the other two, so then there will be cis trans isomers. Cis trans isomers. For example, platinum NH3 and Cl2. So this shows cis trans isomers. So this is very common example, square planar complex with two pairs of ligand as the anti-cancer drug cisplatin, whereas cisplatin has beneficial medical effects by binding to DNA in cancer cells. Transplatin cannot be used in cancer treatment. For example, this can be drawn like this: platinum NH3 Cl. So draw wedge, two wedges and two Cl. So this is cisplatin and cisplatin is anti-cancer drug. And which is beneficial anti-cancer drug. Sorry, it is anti-cancer drug and has beneficial medical effect by binding to DNA in cancer cells. So on the other hand, platinum NH3 and two different ligands so this is transplatin. This is common example of square planar complex with two pairs of ligand. One is anti-cancer drug cisplatin and other is transplatin, which cannot be used in cancer treatment. Cannot be used in cancer treatment. Identification of this cis-trans isomer. If cis isomer has identical ligands are 90-degree apart. Identical ligands are 90-degree apart. And if identical, this is for cis isomer and trans. For trans identification, for trans isomer, if identical ligands are 180-degree apart, that is trans isomer. For example, look at this Cl, this is 180 degree apart. Cl, sorry, over here NH3, and this is also 180-degree apart. 180-degree apart. And in case of cisplatin, there is identical ligands are 90-degree apart. Like this, 90-degree apart. So in this way we can identify the cis-trans platin. In octahedral complexes, octahedral complexes, it exhibits geometrical isomerism, if the complex sign has two ligands attached to it, it are different to the rest 4 ligands. Then it can display cis-trans isomers. Two positive. In this molecule, the two water ligands are next door to each other in the cis isomer and are opposite each other in the trans isomers. In this, like, two water ligands are next door to each other in the cis isomer and are opposite in the trans isomer. On other side, that two water molecules, if form a 90-degree angle, then it is cis, and if form 180-degree, then it is trans. So look at the diagram. This is trans isomers. This is trans isomer and this is cis isomer. If it is drawn like this, So this is cis isomer. So there is another example when bidentate form in nickel En2 and Cl2. So this is nickel Cl and this is wedge, this is solid line, this is wedge, and this is dotted line. So if NH2 CH2 CH2 NH2 and NH2 CH2 CH2 and N. So this is cis isomer of octahedral geometry, cis isomer, and if Cl like this, and this is dotted line, wedge, so N CH2 CH2 N, and other molecules like NH2 CH2 CH2, and this is N. This is trans isomer. Optical isomerism, octahedral complexes with bidentate ligand. Ligands have also optical isomers. The two forms are superimposable mirror images of each other. They have no plane of symmetry, and one image cannot be placed on the top of the other. So in this case we can, for example, if M is metal and A is the ligand 1 and B is the ligand 2, then there are certain possibilities. In case 1, if Ma6, so all the ligands are the same, so no cis trans isomer. When all the ligands are same type, no cis trans. Number 2, if Ma5 B1, no cis trans. Octahedral. Octahedral. If optical isomers are only possible in octahedral if two bidentate ligands are present. Octahedral. So two bidentate ligand, two forms that are simple. But in case of like cis isomers, if these symmetry are there, then cis trans isomers are present. But if two bidentate ligands are attached with the octahedral complexes, then optical isomers are present. For example, Cu this is mirror image of so this is mirror image of each other. Mirror images, and this is example of Cu En3 2 positive. Similarly, there is another example, platinum oxalate 2 and Cl2 and 2 oxalate carrying -4 charge and 2 Cl carrying negative charge. So -2 and -4, it is 6. So if this is 3 minus, the platinum carrying 3 positive charge, so 3 minus 6 is equal to -3 charge. Overall charge is -3. So we draw like this: platinum, Cl, mirror image of platinum, so this is mirror image of each other. Non-superimposable, and mirror image of each other. Mirror images, and both are enantiomers. It is also known as enantiomers. So this is all about the isomerism in transition complexes. Hope you would like the. If you like this, please subscribe and share this video to others.